Hello YouTube, today we are going to use the sieve of eratosthenes to find primes and twin primes and demonstrate two twin prime conjectures. The sieve of eratosthenes is a method for finding primes where, starting at 2, eliminate all of the multiples of numbers, and the only numbers left will be prime. The algorithm is faster than a linear algorithm up until 10 billion. To start, we will declare M for maximum and an array of true statements with a length of M. You can set the array to any value, but we will set it to true as you will see later. We will create a for loop that will loop through the array. We set the range limit to the square root of M because if I squared is more than M, then we know that any composite number less than M must have a factor less than I. The reason we set the array to true statements is because if statements, where there is no equality statement, defaults to if it equals to true. We check if the index of I is true so that we can eliminate the multiples of the primes. The for loop of C is to eliminate multiples. You might not know that the range function actually has 3 arguments, start, end step, which is the increment, since the range function actually creates a list. We start at I squared because any multiple before I squared must have a multiple that is less than I and the multiples are already marked composite. Index C, for composite, is set to false to mark a composite number. We iterate through the array to check for true values, the indices being the number, and print it. Although Python is notoriously slow, this algorithm is insanely fast. Even a slow computer can compute 1 million primes in a short amount of time. We can use list comprehension to compress the for loop into one line and create an array of primes. We can use a sliding window technique to check for twin primes, or primes that are 2 numbers apart. We have 2 variables that increment at the same time creating our sliding window, and we can subtract the array values and check if it is 2. Then we can print an F string to make it easier. Another twin prime conjecture is that the digital root of a product of twin primes is equal to 8, an exception being 3 and 5. The digital root is the sum of all of the digits, repeated until you get to one number. There is an equation to find the digital root which is divide by 9 and find the remainder, also known as the modulus function. Thank you for watch.